I mean, I think this is a perfect segue. Let's talk about AI. And since
I
you
walked into that one, didn't I? All right.
all right. So I know you've given a lot of talks on AI, and I just want to preface for the fact that for the longest time, and one of the challenges is there's never really a large database of lesions to train the AI. And you're the person who was instrumental in sort of brought the entire international community together and pooled the resources, collected all the images so that everyone out there, some computer and just geniuses can sit in the internet in their garage, they can basically tap into the database and do the work. So why don't we talk a little bit about that? Like, what are the necessary component to develop an AI?
So yeah, obviously, once I start talking about AI, we can go at this for hours. And I think, now just about everybody who's listening to this is beginning to understand that AI is changing everything in the world around us. And there are different kinds of AI. There's text-based AI, and everybody right now is familiar with these new chat bots and the fact that you can almost talk to a computer like another person, and do searches where AI does all that for you. And that's going to have a big impact in medicine as well. But here we're really talking about image-based AI. And there too, we've gotten to the point, if any of the people listening have tried it, you can now create original art using AI,
Yeah.
and you can use image-based search, right, where you point to just about anything, take a picture, and Google's going to take you to a search as though you knew exactly what you're looking at. So here we're talking about simply trying to leverage the power of modern day AI for earlier detection of skin cancer. But to your question, what does it take to develop AI? It's important to understand that the new generation of AI, because computers became so powerful, both in terms of storage and memory, and because of these new algorithms, which are referred to as machine learning or convolutional neural network, the current generation of AI learns the same way humans learn, the same way kids learn. It's by looking at a lot of examples that have been labeled for them. And the reason driverless cars can actually succeed is because we have helped label hundreds of millions of images, okay, of things that were taken. Every time you do a catch on one of those, are you a robot or not? And you help it find the traffic light or find the bus, you're really training AI to recognize the kind of things that you need to do a driverless car. In medicine, the problem is that most of those images, because of privacy concerns, are not available to computers to learn from. And when they are available, they haven't been labeled in a way that the computers can learn from them. So to your point, what we've been doing with the International Skin Imaging Collaboration, which is, as you alluded to, it's a collaboration of over 50 members from around 5 continents, is to try to begin to address that problem by gathering images from a lot of different places in different melanoma clinics around the world and labeling them accurately and making them available to computer scientists to develop AI. I do want to point out it's still early in the days, and to give you some idea, we're very proud of ourselves that we put 70,000 images into the public domain. One of the members of our AI advisory actually works for one of the very big computer companies. I won't say which one. And I had a conversation with him last week. Their new foundational AI algorithm has been trained on 14 billion images.
Oof.
So we've got a long ways to go, but I think
But
we're
I have to say,
progress.
some of the published data coming out of it, and you're fully aware of it, right? Like, why don't we talk about that? How good is the AI right now at this point? And from some of the studies that shown in comparison to the expert demoscopist or melanoma expert.
So yeah, and I think, and we've published, several of those studies, and our challenges through ISIC have actually invited thousands of computer scientists to compete to see who can come up with the best AI. And there have been programs that look amazingly good in these artificial tests. And so if you limit the number of diagnostic categories that you give the computer to 9, right? And it's been trained on all 9 diagnoses. Some of these algorithms have 98% accuracy, 97% accuracy for finding melanoma. The problem is they were trained on the same images that we're testing them on to some extent. And that doesn't mean that they would perform well in the wild, right? And there are companies out there that have already made AI diagnostic apps available. In the US, it's been limited because of regulatory oversight of the FDA, but in Europe, these have already been used on millions of lesions. And the short answer is they're good. They're not as good as a good dermatologist yet, and they can be fooled. So I would say my answer is it's really promising. And when we get much larger data sets that are much more representative of all the things that really happen on people's skin and all the different kinds of skin people have, then it's going to be a huge step forward.
So I'm gonna ask you one more question. And what do you think the limitation is of AI? And mind you that I also typed in Chat GPT the same question.
All right, let's hear it. Okay.
No, you go first. You go first, and let's hear let's see if your answer is the same.
So let me start by saying I actually gave a grand rounds on AI and dermatology over the last couple of weeks, and in preparation, I put into Chat GPT-3 the 3 words AI and dermatology and asked for a brief essay for a professional audience and got back 3 paragraphs that pretty much summarized my entire 1-hour lecture. And I shared that with the audience as well. So yeah, so I'll be curious to see what it comes up with. And the answer is it's just like what you're doing with ChatGPT 3. As long as it's used intelligently, I think AI in dermatology is going to have a place sooner than later. But one has to recognize it's not infallible. And right now, in fact, it's not even what I would say great. And so it's like any other test. If used well and used wisely, it's going to bring real value. But the question is, how will we insert it in what we call the clinical care chain, so to speak? Because it can be used at every level, from patients themselves using an app, trying to decide, do I need to see the dermatologist, to non-dermatologists using it to decide, do I need to send them to the dermatologist, to dermatologists who are even experts using it to say, make sure I'm not missing something here, right? Yeah. So for each one of those different scenarios, it needs to have what we call different performance characteristics. And so it's like any other tool. The key is to use the right tool for the right purpose and know the limitations of the tool. And it's the person using it who still has to be responsible for understanding what they're doing.
No, I like the description about you basically can reset the ROC curve and the sensitivity specificities for the patients. You don't want to miss any melanoma, so the sensitivity could be really high. Whereas on the other end of the spectrum, the dermatologist, you want to be very specific, so you perhaps don't have to over biopsy.